Okay, let's get started for today's session. As you already know, we are into the fourth week of the semester, and previously we were looking at this topic, ANN, which we almost concluded. Just a few more minor comments, and then we'll be officially concluding this, right? So, just to recall you, in the previous week, we started a discussion with the multi-layer perceptron, where we saw how you can solve different problems using hidden layers rather than you can say a single perceptron which was able to solve only linearly separable problems. So we had seen what is a forward pass where you have some input, you multiply by weights, you apply the activation function, and then you repeat this process for every layer, and eventually you have the output, right? And then most of the discussion in the previous session was dedicated to backpropagation. Backpropagation is actually an algorithm that you use to learn the weights of a neural network, right? So initially we initialize the weights with some random values. We have training data where we have input and we also have the target output. So we saw how we can compute the error, which is the difference between the target and the actual output, and then we backpropagate it to previous layers where we saw with a numerical example how you can actually learn the weights of a neural network, right? So you must remember that there was an extensive use of chain rule because for the last layer we have the target, so we can easily update the weights. But for the initial layers, since there is no target for initial layers or the intermediate layers, so whatever error we have at the final layer, we actually back propagate it, right? And using the chain rule, we update the weights. Okay. So there's a numerical example which we did last time, but as I'll tell you today, uh, you will have I'll discuss with you your assignment number one, in which you'll be doing the same thing, that you will be solving back propagation by hand, and you'll also be implementing a neural network, right? Okay, so for today, we'll start with a walkthrough of how you can implement a simple MLP in Keras or TensorFlow, right? So again, I'll not be explaining each and every you can say statement in this course. I'll just be sticking to some basic or important aspects of this program, right? So this first example is solving actually a two-class problem where we have labels like 1 and 0, right? So this is a famous data set, which is PIMA diabetes data set, which has 8 features, right? It is a CSV file. And the objective is to predict whether a subject has diabetes or not, right? So it's a binary classification problem. So we want to solve it using an MLP, right? So what we do is we load the data. The first 8 columns are actually the features, and finally in the last column you have the label, which is 1 or 0, right? So we are loading all the features in variable X and the targets in variable Y. Then, as we did last time, we create a model. So in the first layer, we have 12 neurons, right? Then we have the second layer where you have 8 neurons. And since it's a binary classification problem, so we have just one single neuron in the last layer with sigmoid activation function. As we discussed in the previous week, the number of layers, the number of neurons in each layer, these are hyperparameters which you can choose through hit and trial or through experimental study, right? So for this particular problem, since we have the 8 features, right? So we don't need hundreds of neurons. Maybe I have just randomly picked say 12, 8, and 1. You can experiment with other combinations of number of layers as well as number of neurons, and you can come up with an optimal architecture, right? So as we discussed last time, whenever you are solving a two-class problem, we use binary cross entropy as a loss function, right? And this model.fit is actually the key function which performs back propagation, update the weights, right? And this 150 is the total number of epochs after which your, you can say, training will stop, right? And this batch size is 10. Once we were studying gradient descent, so we studied that normally we use mini batch gradient descent where you see a small batch of training example, you update the weights and so on, right? So for this example, we are not making a distinction between training and test set, right? This is just a basic, very basic example. So once the model is trained, we evaluate the model on the same data, right? But of course, for practical problems, you will not be doing that. You will have a separate training and test set, right? But since this was a very basic example, so we are actually evaluating the accuracy of the model on the same data on which it was trained, right? But of course, for practical applications, it will not be like that. So I'll provide the complete source of this example in a practical that I'll show you in a while, right? But before that, let's see one more example. Uh, this is again a very famous data set which all of you must have seen in your machine learning course, which is the iris data set, where you have three classes, right? So again, just like we did previously, we load this data, okay? And a thing which is slightly different here is that it is not a binary classification problem, it is a three class problem, right? So once it's a three class problem, it means in the last layer, we need three neurons. Okay, so here you see three, and the activation function would be softmax, right? Because for two classes, we normally use sigmoid activation function, and for multi-class problem, we use a softmax activation function. And the loss function we use for a multi-class problem is categorical cross entropy. So you can we have four features, right? So we have again three layers with 8, 4, and 3 neurons, and you can you can replicate this code and run it. And again, in this example, we are not making any distinction between training and test sets. Whatever we are training on, we are testing our model on the same data, right? So again, you can replicate this and play around with different hyperparameters to see how your the performance of your model varies when you change different hyperparameters. Okay, now I'll talk about quickly about our first assignment. It has been uploaded on LMS, right? So the first task that you will have is that this network is given. Okay, more details are in the description. I'm just discussing so that you know well what actually is required. So a small network with one hidden layer and one output layer. It is provided. All the weights are given. So you just need to perform a forward pass, right? You have the target, you have the output, and then you need to perform one single backward pass, right? So in other words, you will be showing one iteration of back propagation by actually not writing a computer program, by solving it like a numerical, just like we did in our previous weeks, right? So it's fairly simple. The whole idea is that when you solve it by hand, you will understand fairly well how actually weights are updated, right? So whatever is being done in this function model.fit, you will be doing only one iteration of that to understand how actually things are working, right? So this would be the part one. Part two in your assignment is basically implementation of digit recognition using multi-layer perceptron, right? So since it is not a programming assignment, so you are free to actually get help from anywhere. In fact, the source code which is provided in your slides, you can replicate it, right? And I have already provided you a function as well as data. The function will be loading data for you, right? So you don't need to actually write anything from the scratch. Utility functions are provided. I'll show you. You can simply download that Python file, and you can add your own model to that program, right? And the actual data set has, I think, 21,000 images. They are very small, 32 by 32, I think, or 28 by 28, not more than that. So you would be able to run them easily on a normal machine, right? You don't need any high performance machine with a lot of memory to run this model. But still, in case you have any problem, you can use a small subset of database, right? Although there will not be any problem, but still, if any one of you find a problem of memory, there's no need to use the complete data set. You can use a small subset of a data set, like, for example, only 500 images per class and so on, okay? So let me just give you a bit more details that how you will be solving it, right? So you will have maybe a data set in which you have images like this, okay? And the program which will load data that I will provide you already, right? So I'm sharing with you a screenshot. This is what I have already provided you, right? So all you need to do is, you see here, you can give the name of the folder in which you have the images. You can download images. I have also provided them. And then these labels, this is your Y, okay? And this data, this is your X. So afterwards, you can simply open your slides and make a model, 4 to 5 lines of code, and then you can actually run this program. But the important point is that, as I told you, that this is the objective is not programming, okay? This is not a programming assignment. The main idea is that you will be preparing a report, okay, just like you prepare research papers. Okay, so we expect that the report starts with a small abstract, then you have introduction, that what problem you are solving, then maybe you describe the data, okay, what data set you are using, and then you have a section on methods, right? This is your key section in which you introduce your model. Everyone will have a different model, right? Because everyone will have different number of layers, right? Different activation functions, different number of neurons, and so on, right? So you can have, okay, this is my model, something like this, whatever your model is, and then you can actually give the details of the experiments that you perform, right? And finally, you can end up with a concluding remark, that what you concluded and what you inferred from the experiments, right? So whenever you are doing experiments, you see you will have, say, some model, you will give it some data, and you will have, say, some number that, okay, this is my accuracy for this classification problem, right? But whenever we are doing some research or solving a problem, we don't do a single experiment, right? We are interested in studying what is the effect of different parameters on our performance, right? So what you can do is, for example, you can say, okay, I have one hidden layer, two hidden layers, three hidden layers, four. So how my performance is changing, right? So on this axis, maybe you have accuracy. So you say, okay, when I increase the number of layers, my performance increases, right? But maybe after three layers, the performance becomes stable, or whatever is the case in your experiments, right? Similarly, you can say, okay, when I increase the number of neurons in my hidden layer, my performance increases. But if I use too many neurons, then maybe the performance starts to go down. Maybe the model is overfitting, and so on, right? Another interesting study could be that when you are solving, say, a digit recognition problem, so you see maybe 6 and 3, they are very different, right? But in some cases, 1 and 7, they can be to some extent more similar as compared to other classes, right? So you can have a confusion matrix, right, where you say, okay, which digit is giving you more error, right? For example, you can have, say, digit 0, digit 1, digit 2, 9. So for 0, you have a very good accuracy, but maybe for 1, you have slightly less accuracy. And maybe for digit 7, you also have relatively less accuracy, because sometimes maybe model is able model is not able to distinguish between 1 and 7 because they look very similar, right? I'm just giving you examples that how you can enrich your report, right? And whatever we are discussing, this is not only applicable to this assignment, this is applicable to your thesis, this is applicable to any assignment that you are solving in any other course, right? So whenever you are preparing a report, please enrich it by experiments, right? The more experiments you have, and whenever you do experiments, you get some result. It is not sufficient simply to say that, okay, I did this experiment, I got 80%, right? You have to do some analysis that, okay, why I'm getting less performance or maybe better performance in this with this configuration as compared to other configuration, right? So if you do that, this will actually help you in your research, as well as if you're writing a research paper, okay? So more details you can find in the file that is shared on your course web page, as well as on Piazza, right? So if you have any problems with that, you can let me know and we can discuss. Okay, now this actually concludes our discussion on ANN. But before we move to the next topic, I'll also like to share with you that on your course web page, I have uploaded just for your you can say guidance, some practicals, right? For the time being, only one practical number 1 is uploaded, which is actually a stepwise guide that how you can do implementation, right? Because if you're not very much familiar with Python or TensorFlow, you can just read this, okay, and you see every step has a detailed explanation, which we did not which we did not do in the lectures, right? Every single statement is explained, that how you load data, how you create model, how you compile it, and then how you can call the fit function for back propagation, and finally how you can evaluate the model, right? So this is not something that I ask you that you must do, right? But if you can do it, it will help you, right? This is just for your own practice. So these are the two examples which I showed you in the slides. Okay, there's a complete explanation of what is going on, and you can actually see that the task 3 is actually the similar problem which you have in assignment 1, right? This is also digit recognition. Okay, so you see we already have a model which is solving digit recognition problem, but the difference is that the solution you have in the practical, it is on the MNIST data set, right? So please be careful that the practical which is only for practice purposes, it is on MNIST data, right? But the assignment that I have uploaded is not on MNIST, right? This is on a different data set which is called CVL digit data set, and the data set I have also provided you a link, and the data set is also uploaded with the assignment, right? Since on LMS there are restrictions, we cannot upload a zip file or a PI file, right? So you can download the complete package from Piazza. It has the data as well as a PI file with some utility functions, right? So with that, we'll conclude this introductory, you can say, discussion, which was related to some leftover implementation from ANN and some guidelines on your assignment. If you have any comments or queries, we can discuss before moving to the next topic.